Okay. So in our last class, we discussed about the union and unional, and also we learned this. We learn about the views, types of views, and all right. View advantages and then disadvantages also we learn. Today we are going to learn about the indexes. Today we are going to learn about the indexes. What is index? What is why we will go for the index? We'll discuss in details. Without index, what is the problem, and then with index, what is the advantage, and then how this index is going to be solve the problem in database. We will see. First of all, what is index? The main goal of index is the main goal of index is it will make search faster. Actually, it will make search faster. Okay, whatever we are searching in the database, whatever you are searching in the table, so that will make the search faster actually. Okay, that will make the search faster. That is the main goal of index actually. The main goal of index is to make your search faster. Normally, even in textbooks, okay, so textbook will have the index. Why will have that index in textbooks? So to find out the lesson very quickly, we'll have the indexes. The same concept here, guys. Okay, the same concept here. So whenever we want to search data or record fastly, then we'll go for the indexes. Okay, so let me go with the Excel. Suppose when you create a table without indexes, let me zoom it. So just imagine that we have the employee ID, employee name, and then salary, and then some department. Okay, department you have. Okay, employee ID something you enter like so 12 and then 8 and then 14 and then some like random numbers, like when you without have index, like however the way you insert, so the same way it will be inserted like a 40 and then 45 and then 60 something. You are inserting your employee and then employee name something A and then BBB and then DDT and then YYY and then so you have some, so you have the data like this. Okay, you have the data like this and then salary some, you know, 90,000 and then 7,000 and then 50,000 and then 30,000 and 20,000 and again 50,000, then 70,000. Okay, and then department you have the IT and then HR and then again IT and then HR again, audit again, and then we have the sales. Okay, and then sales. Just imagine that. Okay, so you have the table like this. So when you create the table, okay, let's go to the SQL Server and then create a table. Okay, so whatever the way you insert the data, so the same way it will be inserted, but it will not sort the data actually. Okay, let's see whether it is sorting the data or not. Let's see whether it is sorting the data or not. Let's go with the new query, and then our database is MSBI. So let's go and then select the MSBI samples, and then create a table. Whatever the table I said, create. Whatever the table I said, create table EMP. Okay, so EMP table I'm creating. So if this table is exist, and drop table if exist. Okay, if this exists, drop table name. So you can write that, and then you can go with the open bracket and then close bracket. So here, so what are the columns we required? So like what are the columns? Employee ID. Okay, employee ID like integer, and so then you will have the comma, employee ID integer comma, and then name, and then varchar, 10, 10 you can say, varchar 10, and then comma. So next, what is that? Like salary. What is that? Salary, and then salary integer again, and then comma. So after salary, you have the department. Okay, you have the department. That is also varchar. You can say like 10. Hmm? So you are creating a table. So if the table is existed, so I'm dropping the table and then creating a table. Okay. Now insert the data. So if you insert the data, insert into table. So what is the table? EMP, and then values, and then you can insert the, like, so same this values. Let's go and then insert the values and then open bracket and then close bracket. So like you can go with the comma, and then you can have the quotes, and then again you can have the quotes name and then comma, and then you can also have the comma, then you can also have the, so I'm inserting the data, guys. Inserting the data, so you can say comma and double quotes and then comma and comma. Oh, sorry, I'm not presenting the screen. I'm presenting the screen, right? So everyone able to see my screen, right? Hello,
Yes, yes, yes. You can see the screen.
Deepti. I'm presenting the screen actually. Okay, so you can give a close bracket and then you can give a comma, and you can have the open bracket here, and then you can also have the close bracket. So the insert command I'm not going to explain, but I have already explained about this. So please go ahead and see the insert thing, guys. Okay, like, you can have the comma separated for each and every row. Comma. Okay, let's. So this is, instead of quotes, I have given the comma inside actually, just okay. So this way you can go and you can go ahead and create a table and then insert the data. So but if you select the table, right? So this, if you select this table, if you select this table, select star from this EMP. Okay, this is EMP. See, there is no order. Like whatever the order you have given, so the same order it is inserted the data. It is inserted the data, right? So there is no like proper order. There is no structure actually. There is no proper structure. This is nothing but a heap structure. Okay, this is nothing but a heap structure. Okay, there is no, like, if you don't have the any indexes on a table, it will not have any structure. If we don't have any structure, that structure is nothing but a heap structure. So when you have a heap structure, when you are suppose if you have 1,000 records, like if the 1,000 records there in the somewhere in the, like, below, like it will go row by row. It will go row by row, and then it will search each and every record, and then it will find the, like, after, like, uh, 999 record, it will go and then find that. So like, even it will be, even that we cannot say that it's after 999 records, like it will be somewhere else. Okay, it is not having in a proper order, right? So that is the reason. So you cannot say that it's like, on um, which read you can find that record. Like it will go row by row, like whatever you are searching, it will go row by row. And then this is nothing but a table scan, guys. Okay, it will, if you go row by row and then find the record, is nothing but a table scan. Okay, so the entire table you need to scan and then find the record. This is called a table scan. When the heap structure is there, so that is going with the table scan. Okay, when you have the heap structure, that will go with the table scan. Okay, so the advantage and disadvantage of the table scan is like, so if you have the insert, update, and delete, and then select. So when you have in a heap structure, right, so insert will be fast, insert will be fast, and then update will be fast, and then delete will be fast, but select will be slow. Why? Let me give an example, guys. Let me give an example. So sorry, it is fast. Okay, it will be fast and it will be slow. Okay, so for example, you are vacating one room, and you book the movers and packers, and then they they just they just bring all the samples, and then whatever the new room is there, so just they dump the all the items. Okay, all the items in one area. Okay, so it's very simply like they are dump the data, and everything will be easy when you are in a heap structure. Like if inserting a record is also very easy, but when you in a sorted order, right, when you have in a sorted order, so inserting record is not that much easy. Like so you are not stopping any resource. Like when you have the heap structure, you are not stopping any resource. Like so whatever the movers and packers vehicle is there, right, so the vehicle will dump the data, just it will like the hall like just they will keep the items in a like portico, or in the in a hall or somewhere, they will dump it, and then they will go. So you are not stopping any resource. Okay, just a dump is nothing but a insertion. Okay, just you are inserting fast, and then even if you are updating also, like it will be fast, and then deleting also, like it will be fast. So selecting, suppose if you want to select the so and so item, so if the total dump is there, so how you can, so I want to see my laptop. Okay, so where I have laptop, so total dump is there, so you have to search for some time, and then you need to get the laptop. Or you want to search something charger, so you need to first you need to search like all the items you need to search, and then you need to find out. The select item is not that much easy. Okay, so just imagine that you have the lot of items, guys. Okay, if you have the lot of items, is that easy, guys, to search that item when you are in a if it is not in a proper structure? Okay, so like just imagine that it's not a room. Okay, it's a go down. Okay, it's a go down. So in that go down, right, there are like multiple rooms are there, like almost 10 to 15 rooms are there. So but before organizing the rooms, like so just them just simply dump that, and then if you want to find out something, like it's a very big garden, just imagine that, so very like lot of items are there. If you want to find some item, so the selection, if it is not in a proper order, it's not that much easy. But if you create a index, right, if you create an index, you will have the item and room number. Okay, you like, so you can say room number and item, so it will have the index. Okay, so in room number 1, I have the total laptops. Okay, total laptops. And then room number 2, I have the desktop. Room number 2, this is the index, guys. Okay, this is the index. And room number 3, I have the mobiles. So how quickly you will go and then pick that record if you have the index? Hello? Yes or no? Are you getting it? So like this, you have the 10 rooms. In the 10 rooms, you have the 10 items. So it is organizing properly, and then you have the index, and then you will skip. Like suppose if I ask you to bring the mobile, so then directly you will go to the room number 3. You will not search for all the rooms. Okay, suppose 10 rooms are there, but if it is not in organized, like so all the items are there in all the rooms, so whatever the rooms you are searching, so you will not find that much easy, right? You need to go with all the rooms, and then you need to search if it is not in a proper order. Are you getting it, guys? And insertion, just to, you are just inserting the record and then updating the record, like very simply you will go and then do the things whatever you want to do. but selection is not that much easy. For that purpose, we'll go with the indexes. Okay, so when you have a indexes, so what is the problem? Indexes, like the insertion will be slow, updation will be slow, and deletion will be slow, and then it will be fast. How it will be fast? Like why it will be slow? Like, so you are stopping the resources, like whatever the vehicle is there, you are stopping the resources, you are asking them to keep, this is the kitchen item, so just you are not asking to dump. So no, don't dump here, just to go this one and then keep that in the kitchen, keep that in the bedroom, keep that in the master bedroom. So you are segregating and then you are moving all the items and then you are asking them to arrange, like it is taking the time or not. So dumping means it will be very fast, but if you are arranging means it will be slow. Okay, if something is there in the hall and then you are arranging as asking into there, you can asking to move that in the kitchen, or like it is not required, so all these things will be slow, but selection will be fast. Selection will be fast. Okay, so now let's see practically whether this will be work or not, we'll see. Okay, let's go here, this will be the green, and this will be like slow. And when you have the indexes, then it will be slow, and then this will be this. Okay, let's see practically, like if you create a primary key, so primary key will create a which index, guys? I said, like we discussed about the indexes, so like we discussed about the keys, actually primary key and then unique key. So primary key will create what kind of index it will create? Hello? Cluster index, right? I hope you are not practicing it, but practice it, guys. Okay. So I'm going with the primary key. So primary key will create the cluster index. Primary key. So primary key. So I'm just again I'm dropping the table. I'm dropping the table and then creating a table, and then inserting the data again one more time. And then if you select the table, so the data will be organized actually. So it will go by default. It will go from ascending order to descending order. So primary key automatically sort the data, right? It is sorting the data or not? Hello? But if I insert any record, if I insert any record, like suppose if I insert so and so record, if I insert like 41 record, if I insert 41 record, so it has to look all through, and here you need to, between you need to create a space, and then there it should insert, right? There it should be inserted, right? And let's see whether it is inserting between the 40 and between 45. Let's go and then insert this, execute and then select the query, so whether it is inserting after 40 and then 41. Hello? So it need it, what internally what it need to check, like it need to check like where is the 40, and after that 40, like so do we have like 45, so in between this need to be create a space, and then it needs to be insert the record. So it will take some time or not. Okay, we have a very less amount of data, that's the reason here you cannot see that. But in real time, like when you go with this, and then if you want to search, like and then insert a record, little bit slowness you will have in the insertion actually. Okay, so by default, like how to check whether we have the, like what kind of index is there, not so we have the one syntax, right? So what is that? Sp, like I have explained this one, sp underscore help index, to check the whether you have the indexes on table. So and after that you have need to give the table name here, table name, yes or no? So if you want to check this, so like primary key by default it will create the cluster index, sp underscore help index, help index. So this will be create, like so you need to give the table name, and this will check the whether you have the indexes are on table or not. Okay, so this is created the cluster index. So when you have the cluster index, right? So when you have the cluster index, definitely it will create the, so it will sort the data automatically, and then, but it will make your search faster. How it will make your search faster? Okay, actually it will create the binary structure. What is binary structure actually? What is binary tree structure? Okay, so far what we learned, like what is index, and then what is a heap structure. Heap structure also in learn, and then so how we are, like when you have the heap structure, like so how it is scanning. Suppose if you are searching for like one, like it will go in a sequence order, like one, two, three, and then four. Suppose you are searching for 100. Okay, you are searching for 100. So you're searching for 100. Like so, how many scans you have to do? Like 1, 2, 3, 4, 5, 6, 7, up till to find 100. You need to go with the 100 scans. 100 scans. That is called a table scan. Okay, without index, if you are searching something, that is called a table scan. So hope you are clear what is the table scanning, right? Simply you can, so these are the index interview questions, guys. Okay, these are the index interview question, and then you need to, once you understand the interview, like indexes, you'll answer all this. Okay, what is index in means it will make your search faster. And what is heap structure? Heap structure means if you don't have any index on table, so it will not have any proper structure, proper order, so that is called a heap structure. So so like what is the advantage of disadvantage of heap structure? When we will go with the heap structure, and then when we will go with the like indexes, we'll also discuss that. And but the advantage of the indexes is like insertion, updation, and deletion will be easy, fast. But table scanning, like the search will make slow actually. Whatever you are searching, that search will make slow, right? And then so now we'll understand what is b tree structure. B tree means binary tree structure. Binary tree structure. So what is binary tree structure? What is binary tree structure? We'll understand what is binary tree structure, guys. Okay, so let's go open the paint. First we'll have the root nodes, guys. Okay, first we'll have the root nodes. In this root nodes, right, so it will have the index only. Okay, in this root nodes it will have the indexes, like so, like you will have the, so suppose just you have the 1000 records. In 1000 records it will have the 10 pages. Just imagine that it will have the 10 1, 2, 3, and so on. So okay, I'm not going with all the things, but here this is the page number 1. Okay, in the page number 1, so how many records are left? Like 1 to 100. 1 to 100 records is there. And page number 2, so in page number 2 you will have the 1 101 to 101 to 200 records are there. Okay, in page number 3 you will have the 201 to 201 to 300 records is there. Like this you will have the references. Okay, under this you will have the again pages. Actually again you will have the multiple pages. So like it will have like this, sorry. So you have the page number 1, have the page number 1, and then again page number 2, again 10 pages. Just imagine that you have the 10 pages here. Okay, so what these pages will have, again this pages also will have the indexes. Actually this pages also will have the indexes. Again it will also have the, okay, so it is connecting with this one, and it connecting this one, and then connecting this one, and then connecting this one. Okay, so in this page, right, so this is the page 1. Again this is the page 1. In this page 1 again you will have the 1 to 10, and this is the page 2, and here you will have the 11 to 20, and here you will have the page 3. So here you will have the 21 to 21 to 30. Okay, so like this Here it will have 100 records, and then again next 100 records, next 100 record, next 100 record, next 100 record. Like each page will have this 100 records. Yeah, clear. And then again below also you will have the, again this one will have the again 10 pages. Okay, this one will have again, sorry, 10 pages. This one also will have the 10 pages. So like here you will have the page 1, page 2, page 3, page 4. Okay, so like so on so pages. So I'm not going all the pages, guys. Just imagine that. So again this one also will have the 10 pages, this one also will have the, this one also will have the 10 pages. So this is nothing but a root nodes. Okay, this is nothing but a root nodes. This is nothing but a intermediate nodes or branch nodes. Intermediate nodes are branch nodes. We'll also call it as a branch nodes. So whatever the below we have, right? So this below we, whatever we have, this is nothing but a leaf nodes. Okay, leaf nodes. Okay, so here again we'll have the data, and then um, indexes, and then data will be together. Like so, you have one. So it should have the one employee ID, so and so, and the so and so name, and then so and so salary, so and so salary, and so and so department. So it will have all the data. So this leaf nodes, right? So it will have the data. Are you getting it? So so and so employee, and then so and so number, and then so and so salary, and so and so department. So it will have all the data. Okay, it will have all the data. So hope you are getting right. So then 10 records will be here, and then next 10 records will be here. Sorry, so this one, right? So the first 10 records will be this page, and the next 10 records will be this page, and the next 10 records will be this page, and the next 10 records will be this page. Are you getting it? Hello. So hope you are getting right. So the structure, everyone. So like this is called a b tree structure. This is called a b tree structure, guys. Binary tree structure. So whenever you are searching something, whenever you are searching something, so suppose you are searching fifth record. Okay, if you are searching fifth record, what it will do, like it will directly go to this page, like not the second page. So it is not a highlight, like so the first page itself it will go, and then it will 1 to 10, 1 to 100 records it will go, and then immediately it will, like it will not go all this. Okay, it will, so like it will, this this skip, actually all these pages it will skip. And then again in this page, like again you will have this many pages, right? So in this pages also, like it will not, it will directly go to this page, like here 1 to 10. Are you getting it? Directly it will go to this one, and then it will skip all the pages, like so whatever the, this page it will skip, and then this page it will skip, and then this page it will skip. It will not read even in this page also, it will not read these records. Are you getting it? And directly, like it will go to this page, so the page number 1 here. And then so it will directly, like it will check for this first row, second row, and then third row. So you are searching for the third row, right? So directly it will go to this row, and then it will, so these many reads it will be avoid when you have an index. Directly it will go here, and then it will find this. So this is called a, what is this? This is called a binary tree structure. This is called a binary tree structure. It will avoid all these reads, and directly it will go. This is called index scan, guys. So it is like here, it is scanning the, just a minute, guys. It is directly going to this page, and then going to this page, and then again you are searching like 1 2 3. So here you are finding this. This is called a index scan. So index scan, like within a two or three searches you find the whatever you want, whatever the records you want to find, it will find within the two or three scans. You are avoiding all those things in a simple manner, like so this is the pages, right? But simple manner, I will, okay, go to the, where is b3 structure. So in simple manner I will explain, guys. Okay, so hope you understand the structure, I guess, right? So how we'll have the structure, simple manner. So I've given in a simple manner, like so suppose you are, if you are searching, so there is an index. If you are searching, so like the entire this reads, these pages will go, it will not read this directly, it will come here, and then it will search for the, so even enter this row also it will go on, and the only 50 is there, so it will go, and then if you are finding 50, like it will read all these things. This is called a scanning, this is called a index scanning. So like after like 10 reads you find this 50, so but you skipped all these records, so it is saving a lot of time or not? Hello, it is saving a lot of time or not? So but you are, again you are going here like 10 reads, but without 10 reads even I want to get this 50 records, like 50 records, how can I go and then do that? How can I go on then do that? Like you can use the where class, and then you can search for id is equal to 50, then directly, so after going here, like what it will do, it will not scan all these things, and then it will go directly this one, that is called an index seek. Index scan means after finding the index page, and then you are scanning this, and then you are finding the records, right? But even though I don't want to go and then wait for this, like directly I want to scan this one, like this is called a index seek. Are you getting, guys, what is index seek? Yeah, index seek and a index scan, like so it will have the root nodes. Like people may ask you in binary structure what are the things are there: root nodes, intermediate nodes, and then leaves. Root nodes, intermediate nodes, and then leaf nodes. Okay, so this is the way. So like it will, like once you create a primary key, like you can, so it will physical order of the data, and then it will um, it will make your search faster actually. It will make your search faster actually. Are you getting it? So this is the way it will create this thing, and then so actually how you will have the indexes, like you will have the indexes like this. Just a minute. Okay, here you will have the index, and then again you will have the index, you will have the data pages. These are the data pages, data. So like this way you will have the index and then data together actually. Index and then data together. Okay, so this way, so like indexes will require more space actually. Indexes require more spaces. Yeah, so why? Because you require separate space for the indexes, separate space for the indexes, but indexes, but it will make your search faster. It will make your search faster. So how many types of indexes we have? We have, like, hope you understand index seek and then index scan. Now types of indexes. So mainly we have two types of indexes. How many? Two types of indexes: clustered index, and non-clustered index. Non-clustered index. Okay, so first of all, before going to this, when we will go with the index, like so, like if you have the OLTP system, okay, then we'll go with the heap structure. OLTP means like snowflake schema, guys. So in snowflake schema, like so, the tables will be splitted into the multiple tables. Why we'll split it into multiple tables? To organize data, like sorry, to insert the data in faster manners, to insert and update and then delete. So we'll have the, will not have the like indexes. Okay, so like to insert, update, delete, if you want to go like in oltp systems, like after insertion we will have the like we can create the indexes. Normally when you are creating sss package, right? So what sss package, it will take the data and but if you are inserting, if you have an index, right? So if while inserting, if you have an index on this table, so like definitely it will take some time to load the data here. Are you getting it? So that is the reason. First, what like in SSIS package, first we what we'll do, like we'll drop the indexes, and we'll insert the data. Okay, we'll drop the indexes and we'll insert the data, and then we'll recreate the indexes. We'll recreate the indexes. Clear? So that is the reason when you are inserting the data. If it is a OLTP system, then definitely will not have, we should have the heap structure, but after that we'll create the indexes. And then when you have the OLAP means online analytical processing. So we'll go with deep, like what is OLAP and then OLTP. Just so you already heard like so classes on star schema and then snowflake schema, right? So but if you want depth, like again we'll go with the like data warehouse concept. They will there you will understand very clearly like while what is OLTP and then what is OLAP. So, but when you have in a OLTP means online transactional processing. So, whenever you have a daily data, so if you want to insert the data and then update the data and then delete the data, then you will go with the heap structure. But if it is not for like so data warehouse concept, like so where you have the historical data, if you want to analyze the data, then you will go with the indexes. Okay, where you have very less insertion, less updation, and less deletion. So then definitely you will go with the indexes. Okay, clear guys? So that is where we'll go with the indexes. And so how we can decide on which column we will go with the indexes, like how we'll decide to go with the indexes. So only primary key will create the indexes, only primary key will create the indexes, or like what it will create the indexes, when we'll go with the indexes, and which column will go with the indexes. Yes, everyone has that question. So on which column, like which column you are searching mostly, very frequently, which column you are searching, so on that column we'll go with the indexes. Okay, on that column we'll go with the indexes. Clear? And where class and then grouping and then joining. So in joining, which classes you are using in the joining. Okay, so where like so which column you are using in where class, which column, which column we are using which column we are using very frequently in where class, in where, so that column will go and then create. And then next point is that like which columns we are using in group by, group by or order by, group by, order by, and then joins. So like those columns, like even people may ask you how you will decide and then which column we will go and then create an index. Okay, how you will decide. So this is the recent interview question also. Like someone it's asked this question actually, how you will decide to create index on a column. Okay, on column. So like which columns we will go and then create. So which columns we are using very frequently in the where class, which columns we are using in a very frequently in the group by, order by, and then joins. So those columns will go and then create the indexes. Okay, so primary key creating the index, right? Primary key, so this question also people will ask, like primary key creating index, creating index, right? So cluster index it is creating, right? But I don't want to primary key, but I need a, even though if you have a primary key, so I don't want the indexing concepts, can I do that? Are you getting my question guys? So I need a primary key, but I don't want the cluster index, can I do that? Answer is no. Answer is no. So primary key by default it will give the cluster index. Primary key by default it will give the cluster index. But can I create a cluster index without primary key? Can I create cluster index without primary key? Without, answer is yes. We can. We can create without primary key. We can create the cluster index. Yeah. So without primary key, we can create the cluster index. But primary key by default it will create the cluster index, guys. Okay, primary key by default it will create the cluster index. So like first of all, what is this is this will do the physical order of the data. Actually physical order of the data means what? It will sort the data actually, first point. So it will sort the data. So cluster index will sort the data, but non-cluster index will not sort the data, guys. Okay, it will not sort the data. Okay, so here index and data will be together, guys. Here index index and data will be together. Like how you will have the telephonic directory, right? So how you will have the telephonic directory. So the same way, like index and then data will be together here. Are you getting it? So like in telephonic directory, how you will check? Like if you have SA, like what then, like if you are searching for the Srinivas, like SRI, SRE, SRU, SRB, SRC, SR, like this you will go, and then finally you will go with the SRI. SR no. So like the data and then index will be together. But here index is somewhere, index is somewhere, and data will be somewhere. Okay. So that is the reason for it is required, like for indexes also it required separate pages, separate storage. Okay. For this I will show you like how this non-cluster index will have the structure. Okay. For this you required extra space to have index, non-cluster index. But here we don't require extra space. Like it is also required extra space, but how much it is taking the extra space, it will not take that much space. Yeah. And per table, right, we can have only one cluster index, one clustered index, one cluster index. But here you will have more than one, you will have more than one cluster index. You can create up to 999, guys. 999 cluster index you can create. Okay, 999 cluster index will create. Okay, so how non-cluster index will have, like again suppose if you are searching for the um, so how non-cluster index will have, like, so sorry, it will have the separate indexes, it will have the separate indexes. So there, suppose if you are searching for the like what is the table we have, so you are searching for the so and so department. Okay, you are searching for so and so department. So what it will have, like it will have the department information, like department index number and then department. It will have the index number and then department. So like suppose what it will have, it will have the, so department, why it is going this much size, it will have the department. Okay, it will have the department. in the department, right? So like it will have the page number. So sorry, just you can say this is not a, you can say this is a department. This is a department, and this is a like page number and then row number. So here what you will have in this page number, just it will have the reference actually. So here you will have the page number plus row number. Okay. So what is page number? And suppose if you have the department ID, IT, and then sales, and then if you have the HR, like what it will do, like it will go to the so and so page, like page number one, and like and row number, like so in this page. So so and so row number 3, we have the row number 3, we have the this IT department. Okay, it is just referring like how it will do, like it will go to this one and then it will go to this one. So just it will have the references. Are you getting it? Are you getting it, guys? So it will have separate index for this actually. It will have the separate index page. So suppose this is on department column. So like if you have another another column, like you can create a cluster index on multiple columns actually. You can create a multiple columns. Like so each and every column, like whatever the columns you created, it will maintain the separate index. Like so for this index you require a space, and then this index you require a space, and then okay, so this like whatever the columns you create, so that will have the indexes. So what is the question here? This is for non-cluster index actually. This is not for non-cluster index. Non-cluster index. So first of all, cluster index on a single column. Okay, when you have a cluster index on a single column, you can go and then use like this. But non-cluster index on multiple columns, like you can go and then have the separate indexes. Okay, you'll have the separate indexes. Okay, so let me repeat again. So like if you have the index on non-cluster index on department, each department wise, so it will have the department name and then page number plus row number, like so this department where we have this department information. So like it will go to that page. So in this page number 1 we have the department, and then which row you have, the row number 3 we have, so directly it will go to the row number 3. Are you getting it? So just it will have the references. Okay, again if you have the page number 2 we have this, and then row number 10 we have this sales information. Okay, so it will go to the page number 2 and then it will have the row number 10. Okay, so here you have multiple rows, here you have the multiple rows, and like directly it will go to the row number 10. So just it will have the references. So like this, if you have a multiple columns, okay, on multiple columns you will have the indexes on cluster index, non-cluster index. Cluster index on only single column, but non-cluster index on multiple columns. You can create a number of non-cluster index, I said, right? So how many non-cluster index you will create, that many indexes it will be have in a separate space. Hello, am I clear? How many non-cluster index you create, that many non-cluster indexes you will have, this index pages you will have. Yeah, so that is the reason you will require extra spaces, and then up to you can create 999. Yeah, I will come to that point, how to create a non-cluster index. I will come to that point. So first of all, if you want to create any indexes, the syntax of the create index is create index, create index, and index name. Okay, index name, and which table, create index, create index on a table, right? So first like which table we want to create that index on a table. I think we'll have a, just a minute, what is the syntax of the create index name on table. Next, on which table you want to create, on table name you will give the table name, on which column you want to create, on which column you want to create. So this way we'll go and then give the column name here, column name here. Okay, so create index name. Okay, create index name on which table. Like suppose, let's go and then delete, drop this table. We don't have any primary key, we don't have any primary key. And then insert the data, creating and then recreating and then dropping, recreating and then inserted the data. But if you see this, it is not in a structure order. But once you create an index on like a id column, okay, if you create index on id column, so like what is the column name you are giving, like so id column you are giving, and what is the table name you are giving, so employee table, and then what is the index you are giving, like so this is a non cluster index, right? So clustered index, so clustered index, and then index name. So index name is that like ix, you need to follow the rules guys. Index ix and a table like emp table, and which column you are doing id. So this is I'm giving as the index name. Okay, and then if you go and then create this. Okay, so now if you go and then select the data, automatically it will sort the data. So if you want to check whether you have the indexes or not, see, cluster index, clear. So like this you can create the indexes. So create index, like index and index name, and on which table you are doing, and then so like on which column you are doing. So if you want to create a non-cluster index, so just you can go with the non-cluster index, and then which column you want to create. So non-cluster index will not do the any physical order of the data. Non-cluster index will not do any physical order of the data. Okay, so these are the, like, so on which, how you will decide to go like indexes, like we'll go with the indexes, like how to decide like on which column we'll go and then do create the indexes. So which columns we are using very frequently on where class, and then group by, and then order by, and then join, and this class and these columns will go and then create the index. So there is an index fragmentation, like so people will also ask in interview question like what is the index fragmentations. So like you have the data like this. Okay, you have the data like this. So in this leaf nodes you have the data like this. Just imagine you have the like you have the data like this, like employee id 1, and so on so name, and so on so salary, and so on so department. Okay, so on so department like this, 2, and then 3, like and hr. Okay, and 3 we have some ccc, and like you have some, and we have some sales team, and we have also like 4, and you also have the ddd, and you also have the some 4000 records, some department. Okay, some xxx department. Okay, so like this you have the records. Okay, like this you have the records, like sometimes. Okay, so you have a situation to delete some data. Okay, you have deleted some data from this table. Okay, this gap is nothing but a index fragmentation. What is this? This gap is nothing but a index fragmentation. So there is a gap between these two like numbers, like index numbers. So this nothing but a index fragmentation. Because of this index fragmentation, okay, your search will go slow actually. Okay, we need to do the defragmentation. That means you need to fill the gap, you need to remove the gap. So when you need to when you remove the gap, so then again it will make your search faster. How to defragmentation and all we'll see tomorrow. Okay, so we'll also learn like windows functions tomorrow guys. Windows functions very very important in the sql server. The windows functions are very very frequently used in real time action.
Yeah, hi Srinivas. I have a doubt.
Yes.
Yeah, in that any particular database, if we are, I mean, we are facing any issues in the particular database regarding the